So I know in the age of GPS Direct and ForeFlight, using paper charts is a dying art, but I still make my students learn the old-fashioned way with a sectional, plotter, and E6B. So if the batteries ever die on your iPad the day before a flight, keep watching. Okay, a few things. There's no way that I can go over everything that you need to know for cross-country flight planning in a couple-minute long video. So there's a bunch of stuff that I'm not going to go over, like altitudes, weather, route selection, communications, airspace. You get the idea. What I am going to cover is how to go from a line on a map to a compass heading, and then use the E6B to get your estimated time en route and estimated fuel burn. So, here we go. I'm planning a flight from Waterville at the bottom of the page to Greenville at the top. Again, I'm not going to go over any details about route selection. You're going to have to talk to your own CFI about that. I'm just going to draw a straight line. So here's my line. I drew it with the edge of my plotter point to point, and I traced it over with a highlighter so that I could see it a little easier. So now I'll get my total distances. I'm going to use the plotter, and I'm going to use the gauge mark for the sectional chart. The WAC, or World Aeronautical Chart, is a different scale than the sectional, so using that side will result in some funky calculations. So, I put the black start line on my departure airport, and here's my line at Greenville. You can see that the total distance is 56 nautical miles. So next, I'm going to mark off my checkpoints. I won't talk much about how I select them, but I like them to be about 15 to 25 nautical miles apart, so that I can't get too far off of my route. My first checkpoint is about 15 nautical miles away over a road next to Skowhegan. So my next checkpoint is by Kingsbury Pond, and it's 19 miles away. My next checkpoint breaks my 15 to 25 mile rule a bit, and I'll tell you why. I like to call inbound at about 10 miles out when I'm approaching a non-towered airport such as Greenville. Marking it on the map helps my student to know when to make the call, because it can sometimes be hard to judge distance in an unfamiliar place. So my last checkpoint is Monson, 11 miles away, and then 10 miles to Greenville. So now to find our true course. You can see where the course arrow marking is on my plotter, and obviously enough I've placed that over my course line on my sectional. Now I've taken the little hole in the center of the compass rose and I placed that on a spot where my line intersects a line of latitude on my chart. Now, north, south, east, and west are all represented here by different bands, so you'll have to go to the direction that makes sense. So we can just look at the chart and we can tell that we're generally heading in a northern direction, so we're going to look at the north band, which is the top of the innermost white band on the compass rose. You can see that the line of latitude on the chart intersects the compass rose a little less than halfway to the 10-degree mark, so that'll give us a true course of about 4 degrees. So, the day of the flight, you'll get the winds aloft as part of your standard weather briefing. So we'll assume that we'll be flying at 5,500 feet MSL, so we'll be using the 6,000 foot forecast. So let's say today it's forecasted to be 315 degrees at 25 knots. So we'll go to the back of our E6B and we'll put 315 under our true index. Next, we'll put the grommet in the middle on the 100 knot band, just because it's easier to count from there. And then we'll count up 25 knots to halfway between the 120 and 130 bands, and we'll place our wind mark. I put the mark with an X in pencil, and I draw a little arrow to show the wind coming at me, just as a tool to help me visualize it. So next, I'll put our true course of 4 degrees under the true index to represent our course, and bring the X representing our wind down to our planned airspeed of 95 knots. So once we do this, we can see that the wind is off to our left, and the E6B tells us that we're going to need 12 degrees of wind correction angle. So we'll be turning into the wind to keep our ground track on course. So we'll subtract the left wind correction angle of 12 degrees from our true course of 4 degrees to come up with a true heading of 352 degrees. Now remember, we're still working in true because our winds aloft are given to us in true rather than magnetic. So now that we have our x representing our wind on our planned airspeed, all we have to do to get our ground speed is to look at where the grommet ended up. And in this case, it looks like we're going to be slugging along at about 75 knots over the ground. So we'll take that 75 knots over to the front side of the E6B, where we will put our black triangle indicator under the 75. Now the folks at ASA were kind enough to put the instructions right there on these for dumb pilots like me, and you can see that once we've placed our indicator under our ground speed, we can find the distance on the outer ring and read our time en route right under it. So to Skowhegan it was 15 miles, and that'll be a little more than 12 minutes. To Kingsbury Pond it was 19 miles, and that'll be a little over 15 minutes. To Monson, 11 nautical miles, and that'll be almost 9 minutes. And last, 10 to Greenville, well, that'll be about 8 minutes, or about 45 minutes for the whole trip. Now, you may have noticed that some of the numbers don't add up exactly right, and that's okay, as long as you aren't way off. Just remember to round things off in the overestimation direction rather than shorting yourself, just for safety. And if your instructor is okay with it, you can add some time for takeoff and climb out, pattern entry, all that stuff too. So fuel burn is very similar. Let's say the POH tells us that we're going to burn 8 gallons per hour. So we park our little indicator under the 8, and this time it's a little different. This time we're going to find our time on the inner ring of the numbers. So we find our 45 for our 45 minutes, and we read the 60 on the outer ring. Now this is the thing with the E6B. You have to ask, does it make sense that I'm going to burn 60 gallons in 45 minutes with an 8 gallon per hour fuel flow rate? No, it doesn't. So we've got to change it by a factor of 10, because 6 gallons makes a lot more sense, right? So sometimes you have to do that. You have to change things by a factor of 10 when you're working with the E6B. Don't be afraid to tack on a few extra gallons for your climb out, and don't forget to add your VFR fuel reserves too. So you might be thinking, well, what about our heading? We have to fix that, right? We left it in true. And that's right, so let's fix it. Let's figure out what our magnetic variation is. To do that, find an isogonic line depicted on the sectional chart. I have it circled here. And we'll get the value from it. So in Maine, our variation is currently around 16 degrees west. So remember, we add westerly variation and we subtract easterly. So east is least, west is best. So we'll add the 16 degrees to our 352 degrees, and we'll wind up with a magnetic heading of about 8 degrees. So just to recap, we started off with about 4 degrees for our true course. From that, we subtracted our wind correction angle of 12 degrees, which left us with a true heading of 352 degrees. Now to that, we added our westerly variation, and we got a magnetic heading of about 8 degrees. So what you're going to do now is you need to add or subtract your deviation, which is specific to your airplane. You'll find a little card underneath the compass, and once you've factored that in, you'll have your compass heading. So hope this helped everybody. Thanks for watching. Have a good day.